Hello guys, you're welcome back once again to Fun with Physics. In today's lesson we are going to be looking at the effects of pressure. Okay, but before now we actually dealt with high and low pressure, that is maximum and minimum pressure. We looked at cases where we have high pressure being exerted on a surface and low pressure being exerted on the surface. Okay, and prior to the high and low pressure, we were able to establish two facts about pressure. One of the facts is that pressure depends on force directly. That is, when I increase the force, of course I'm going to increase the pressure being exerted. Like for instance, when I increase the force I'm using on a particular surface, I'm also going to increase the pressure. The second established fact is that pressure is inversely related to area. It's inversely proportional to area. Okay, that means when I increase the area, I will eventually decrease the pressure that I'm exerting on that area. But when I decrease the area, I'm going to increase the pressure I'm exerting on that area. Now, in each of these cases, something must be controlled. Remember, the first one, I must control the area, I must keep the area constant. And in the second one, I must make sure that the force is kept constant, is controlled. Okay? Now, these are some of the facts that we've learned, and that is what we're building on. Okay? Now, we are going to be using the textbook, Complete Physics for Cambridge Secondary 1, page 153. If you have it quickly, you can turn to that page and then glance through it to see what I'm about to explain. Okay, I've already established this fact, so there's no need for me to waste much time on it. Now I'll quickly go to this scissors, knives, and tool. The idea of pressure can be applied in a range of situations. Example, when you use a knife or scissors to cut, it is important for you to consider if it's blunt, that is white surface, or if it's sharp. Remember, if it's sharp, it's going to exert much more pressure, right? It's going to exert more pressure because it has a small surface. You're using a steady force. But if it's blunt, it's going to exert a very small pressure. Okay, for you to cut with a blunt knife means that you need to apply an extra force, increase the force, the size of the force, right? The blades of knife and scissors are sharp. They have a small area, so the force you apply produces a big pressure. The blades are sharp, small area, so they give out a big pressure. Now, can you tell what will happen to the pressure when the knife is blunt? What I mean is, when the knife is not sharp, what will happen to the pressure? How will it be affected? Will it be big or will it be small? Okay, mind you, the basic fact about pressure will always help you, will always assist. When the area is big, the pressure will be what? Small. When the area is small, the pressure will be what? Big. Good. When the force is big, the pressure will be what? Big, because they are directly related. Okay? Now, walking on mud and sands. Some animals need to travel across mud, sand, or any other soft surface. Wading birds have flat feet to reduce the pressure on the ground. Like now, in the picture, you have a wading bird. They're walking on a soft soil. It can also walk on marshy areas. Okay, the feet there helps it to spread its weight. Okay, and so exerts a very low pressure on the ground, so it can walk on any soft surface. Okay, the same thing applies to a camel. Very heavy, very large, bigger than a horse, but is able to walk on sandy areas like a desert. Okay, but a horse cannot. You cannot use horse to travel on a desert. Okay, it cannot walk on a desert that easily, but camel do. The reason why camel can travel on a desert or on sand easily is because their feet have wider surface area. Okay, so exert low pressure. The weight is spread throughout the feet. Okay, so it's not exerting as much pressure as the horse. Remember, the wider the feet, the lower the pressure on the ground. Okay, but when you compare that with a horse that has a very small hoofs, you discover that the pressure there will be more in the horse, even though the horse is not as heavy as a camel. Now we have a case like that, a related question, okay? A question to compare the pressure exerted by camel and a horse. Okay? In this question, the question here tries to compare the pressure that has been exerted on the camel and the horse. The camel is, of course, this 5,000 Newton. The area of the 4 hoofs, 1 hoof, 2 hoof, 3, 4, all of it, not just one, because it's standing on 4 of them. So the area of the 4 is 2,000 centimeters square. So the pressure which we can get from this formula, force over area, is 5,000 over 2,000, which is 2.5 Newton per centimeter square. But for the horse that is not as heavy and as large, big as the camel, the weight is 4,000 Newton, and the hoofs are not as wide, so we have 400 centimeters square for the 4 hoofs. When you calculate the pressure by substituting it into this formula, force over area, that is 4,000 over 400, you're going to get 10. Okay, now here you have 10 Newton per centimeter square, and here you have 2.5. So the pressure exerted by the horse on the ground is much more bigger, like 4 times here. Okay, more than the one exerted by the camel. Okay, can you tell the reason why it is so? Even though they don't weigh the same, the camel weighs more but exerts less pressure, and the horse weighs more but exerts more pressure. Do you have an idea why it's like this? Why it's so? Any idea? Okay, if you have your idea, comment. Write it on the comment section of Google Classroom. Okay, to tell me your idea. Now, quicksand. Now, many of you must have seen this quicksand, or maybe you've heard of it, or if you've not seen it in a real life situation, maybe in a movie, you've seen it in a movie or something. So it's really difficult to work on quicksand when you compare that with the sand. Now, the reason why it's difficult is because you exert more pressure and you may likely sink if you're not careful. So quicksand is a mixture of sand and water that are found in places like beaches, swamps, marshes, and so on. We actually rarely find them in desert. Now, sometimes when you look at them, they appear to be solid surface, like a sandy surface, solid. And if you're not careful, you stray on it, you may likely sink. Now, to prevent sinking, to avoid sinking, what you do is, whenever you stray into a quicksand, please try and lie flat. Okay? Can you tell me why lying flat make you to float rather than to sink, or rather than sink? Can you tell me? Do you have an idea why lying flat will prevent you from sinking? Okay, if you have an idea, please comment, write it on the comment section in Google Classroom. Okay. All right, but remember this, that when you stand on quicksand, you may likely sink because your pressure is more than what it can carry. like the friction. Remember, there's a very low friction between the surface. It's sand and water, or wet surface. There's a very low friction, so it will always give away. Always give away. You always slip or slide on it, and if the pressure there you're exerting is too much, it's bigger than what it can withstand, what happen? You may likely sink. Okay, like what we have in the picture there. Okay. Now, another case where we see the effect of pressure is in the road bike and off-road bikes. Now, study the diagram closely, quickly study the diagram, take a few minutes to go through the diagram. What did you observe? What can you observe about the tires? The tires in the off-road bike here, okay, and the road bike. What did you notice about the tires? Okay, can you relate it with the idea you have of pressure? The idea you have, the two facts I mentioned earlier about pressure. Can you relate it? Remember that the wider the surface, the less the pressure. Okay, the force is the same, the force acting is the same, but the smaller the surface in contact, the more the pressure, right? So how is pressure affected by the tires? I've already told you that, I've already explained that. So if the tires are wider, it will make the pressure to be smaller, but if it's narrow or smaller, it will make the pressure to be bigger. Which would you prefer to use in a sandy road, and why would you prefer to use the kind of bike? Which one will you prefer to use in a sandy road? Why? In my own case, I would prefer to use this one here, the one with a broad or wide tires. Okay, now I wouldn't want to use this. This one may likely sink because of high pressure on the high pressure. The pressure it exerts more, right? But this one, at least the weight is being distributed on the tire, so the pressure will not be as much as this one, right? Okay, now we have other examples like where we have other examples on the effects of pressure. Here in the left hand side here we have cases where we have a bigger pressure by reducing the area. Here cases where we have a smaller pressure by increasing the area. Okay, so for a stud here, we know that footballers usually use studs so that they can have a good grip. They keep running here and there to get to kick the ball, right? So they need a firm grip on the ground, so they need a stud, right? So the stud can actually pierce the ground because it's high, so small surface, so it can penetrate. Okay, we've already discussed this case, the case of using a sharp knife and a blunt knife to cut, right? And then the last case here, it's a pin under tiny area. Under the tiny areas of the points of a drawing pin, the pressure is far too high, right? So the pressure here is so much that it can pierce through the wood easily. Okay, now for the case here in my right hand side, we have a scales. Scales have large areas, so they reduce the pressure on the snow so that they do not sink in too far. Okay, so notice that the area there is wide, so it helps whoever it's on it not to sink on the snow. And then this is an interesting one. A wall foundation have large horizontal areas, large area here, below here. Okay, now this reduces the pressure underneath so that the wall here, this wall doesn't sink. Okay, so you have a large surface here. Now the same thing applies to this. You don't want this knot here to sink, to move into the wood there. You can use what is called a washer. A washer tends to reduce the pressure. Okay, and that way the knot cannot move inside the wood as you're tightening it. Okay, now finally, I need you guys to go to Google Classroom. Okay, physics my page. and then answer any 2 questions from here. Okay, just give me a short answer. I want to see your feedback. I want to see what you can actually do based on this explanation. Now the questions can be found, you can actually find them in page 153 of your textbook. Okay, now these are the questions. Explain why the feet of a camel and waddling birds have the shape they have. Can you do that? Then just pick any 2 questions of your choice. Any 2 questions of your choice that it's so comfortable for you to answer, and then write the answer. Okay, and then after that you check back on the assignment section in the Google Classroom to see what the assignment I've posted. Okay, make sure you do it. Are we good? So have a nice day, class, and enjoy the day.